In this lecture, we're going to learn how to change the audio position if the timeline is clicked. Users will be able to play music without a problem. In some cases, they may want to jump to a specific spot in the audio. This feature is common in most audio players. We can replicate this feature by listening for clicks on the timeline. If we detect a click, we'll update the audio position to move to the location they clicked on. The entire process is going to be tricky because we need to figure out where to move the audio position. Let's dive into the code and find out how we can perform this task. We're going to be working in the player component file. The first step is to listen for click events on the player. In the template, search for a comment that says scrub container. You should be able to find it somewhere in the middle. The scrub container element contains the entire timeline. We want to listen for clicks, especially on this element. We don't want to move the audio if the user clicks somewhere else on the player. We'll add the click event listener to the element with the prevent modifier. The name of the function to run will be called updateSeek. We're going to define the function in the store as an action function. The reason we're going to outsource the function to the store is because we'll be changing the state. Anytime we have logic for mutating the state, we should put the logic in the store. Open the store file in your editor. In the action section, we'll define the updateSeek function. The name of the function we're using is called updateSeek. We're using the word seek because Howler uses this name to describe the current position of the audio. Let's go back to the player component file. Scroll down to the script block. In the methods option, we're mapping the actions by using the map actions function. We'll add on to the array of functions we want to map by including the updateSeek action function. Great, we can focus on writing the action function. The next step is to figure out where to move the audio position. We're going to need some information about the event. Luckily, View will always pass on the event to the function handler. Let's accept the event as an argument called event. The click event we have in the player component file directly calls the action function. By default, View will always pass the event object onto the function it called when an event is emitted. We'll need it to help us calculate where to move the audio position. Inside the function, we're going to start by creating a conditional statement. The condition will check if the state.sounds.playing property exists. If it doesn't, we'll return the function. This conditional statement is an extra precaution. It doesn't make sense to move the ball on the timeline visually. If there is a song being played, we'll begin updating the state. There are two things we'll want to update. The first is the ball on the timeline. We want to provide a visual cue for letting the user know their audio has been moved. This includes the time on the left side of the player. The second is the audio's position. The user should audibly hear the song change to a different position. These changes will be based on where the user has clicked on the timeline. We'll need to grab where they clicked on the timeline. Below the conditional statement, we'll declare a variable called clickX. Its value will be the event.clientX property. We have access to information about the event that was emitted. One of the properties we have access to is the clientX property. This property will represent the X coordinate of the click. We're interested in moving the ball horizontally. Its vertical position can stay the same. However, this value is not reliable. I'm going to add a comment to help you better understand why it's not suitable. The timeline we have in the player does not take up the entire width of the page. If the user clicks in the middle of the timeline, the clientX property will not represent the coordinate relative to the player. Instead, it'll be relative to the document. For example, let's say the document's width is 2000 pixels. The timeline is 1000 pixels. If we click in the middle of the timeline, we would expect the clientX property to be 500. The browser will return 1000. The reason it returns 1000 is because the click is registered relative to the document. The center of the player is also the center of the document. The x-coordinate for the center of the document is 1000. This value is what will be returned. If we want to get the coordinate relative to the timeline, we'll need to get the distance from the left side of the document to the left side of the timeline. For example, let's say the distance was 500 pixels. We can subtract the click's x-coordinate from the distance. This calculation would result in the final result of 500, which is what we want. Above the variable, we're going to destructure the object returned by the event.currentTarget.getBoundingClientRect function. The function we're using will return information about the current element's coordinates and dimensions. We're using a special called currentTarget. It's not a property that's used often, but is especially important in our case. In JavaScript, events can be emitted from children elements with parent elements that have event listeners. The element that triggers the event will be stored in a property called target. This property can either be the element that was clicked on the element that has the event listener. We always want to grab the element with the event listener. If we were returned the dimensions and coordinates of children elements, this might cause the player to play audio from the wrong position. An alternative property we can use is the currentTarget property. It'll always return the same element, which is the element where the event listener is added to. On this element, we're grabbing the coordinates and dimensions with this function. The property we care about is called x. We'll destructure it from the object returned. The x property represents the distance from the left side of the document to the left side of the player. We can subtract this from the client x property to get the correct coordinate of where the user clicked on the timeline. We've got the coordinate, but it's not exactly what we need. We need the seconds. We're going to use the coordinate to figure out the percentage of where the user clicked. Then, we'll multiply the percentage by the duration. This calculation will give us the position we should move the audio to. We'll create a variable called percentage. Its value will be the clickX variable divided by the width of the player. The width of the player doesn't exist in our function. We can grab it from the getBoundingClientRect function. We'll destructure the width property from this object. The last thing we'll do is create a variable called seconds. Its value will be the sound.duration function multiplied by the percentage variable. We've successfully grabbed the seconds. We're going to tell Howler to update the audio's position by calling the sound.seek function. Previously, we used the seek function to get the current position. It can also be used to update the position. We'll pass in the seconds variable to tell it to update the position. One last thing. The audio player will not reflect the audio's current position. We should run the progress action function after changing the audio position. We don't need to rewrite the code for visually changing the timeline. We can reuse this action. At the bottom of the function, we'll listen for an event called seek by using the sound.once function. The seek function we're calling will temporarily pause the audio. We're continuously dispatching the progress action within itself. It may notice the audio isn't playing anymore. If that's the case, the action will stop dispatching itself. We don't want this to happen because we know that the audio needs to change position. We can start the loop again by dispatching the action after the audio has changed its position. We're using a function called once. The once function will listen for an event. If the event is emitted, it'll run the callback function passed into it. This callback function will only run once. The name of the event we're listening to is called seek. Howler will emit this event when the audio has officially changed position. At this point, the audio will start playing again. Let's pass in the this.progress function. We're finished. Let's try testing the application in the browser. In your browser, try playing an audio file. While it's playing, click on the timeline to change the current position. The player and audio update correctly. It's the exact behavior we were looking for. We have completed the player. There's so much more we can do, but we'll keep it minimal. I want to shift our focus back to view-related topics.